Hello everyone, and welcome to our webinar on how Splunk uses Splunk Observability to monitor cloud apps, where we're going to go behind the scenes with Splunk's SREs. We're really glad that you're all here and super excited to get started. Before we jump into it, please take a look at the forward-facing statements screen that you see right now, saying that you should make your buying decision based on what Splunk offers today, not anything that we talk about based on our future roadmap. We may make forward-looking statements throughout this presentation. Your speakers for today are myself, an Observability Practitioner Director here at Splunk, Jothikumar, who's a Senior Manager for Cloud Infrastructure, SRE, and Ops for Observability, and Barc, who's a Senior SRE on the Observability team. Today we're going to talk about a lot of exciting things, starting off with what is Splunk Observability Cloud, and then talking about how we use the Observability Cloud, how infrastructure and APM both are necessary to have successful monitoring. We'll show you a cool demo on how we actually use the products to troubleshoot and operate the products, and how we can use our Observability Cloud to speed our time to finding root causes. We also have a Q&A session that's going to be pretty lengthy, so make sure to ask your questions throughout this whole presentation in the Q&A box. We really want you to ask us anything you want to know. We might not be able to answer all of it right away, but we promise we'll get you an answer either in the Q&A session or after the presentation. So before we jump right into the presentation, I did want to talk to you about what Splunk Observability Cloud is. And as you can see up on the screen, it's an industry-leading enterprise-grade bundle of products made for observability, which is really a way to say that this product helps you cut through the complexity of modern architecture and gives you a single view into your application. So we integrate all of the components that you need to correctly and adequately and in the best way possible monitor and operate an application and really your whole business. Right? The Observability Cloud product shows you an end-to-end view of your application, all the way from the user and their browser through your front ends, your mid-tiers, to your back-end services, no matter how complicated they are or where they're deployed. We can handle on-prem, we can handle the public cloud, private cloud, multi-cloud, serverless, we can do all of it, and in a way that performs in real time with fast streaming answers to the questions that you have about how your site's performing and what's going on with it. The Observability Cloud is made up of 5 flagship products. These include infrastructure monitoring, which does what it says, right? It helps you monitor your infrastructure no matter where it is or how complicated it is. We can host bare metal, VMs, cloud-based things, serverless. All of these things can be monitored in our infrastructure monitoring product, and you can see them all in one place. All of the Observability Cloud products all send data into one unified user interface that makes it easy for everybody in the organization to use. We also have application performance monitoring, which is essential as applications are made into a more flexible, containerized, microservice kind of model. They become a lot more difficult to figure out where all the components are and how they interact with each other. Our APM solution lets you find out for any request which services it went to, where they were hosted, what versions they were running, anything you'd want to know about how your experience is for the people that use your site as far as the backends, right, where it's services it goes through and how long it takes, errors, all of that stuff is all again in one place. We also have real user and synthetic monitoring. This helps you get performance data from your users and determine how your websites look to them and how they perform for them. You can see based on actual user data if there's certain parts of your site that are slow or there's third-party APIs that you pull in that are having problems. And then with synthetics, you can test around the world, including really complex workflows, to make sure that your site's working the way that it should be. We also ship Log Observer. Splunk is the logging company, so we have to have a logging tool, but logs are also essential to understand how problems have occurred and what the root causes were. So we wanted to make sure that we shipped a very easy to use, robust log solution in Observability Cloud. So we have this Log Observer product that is focused for the DevOps engineering type audience, where you don't need to write query language, you don't need to do anything complicated to figure out what's going on. The filtering through the rest of the UI applies to Log Observer as well. And of course, you can do regex and other searches to narrow problems down to where the root causes are. And then finally, we of course have incident response, right? Once an incident happens, we want to make sure that your alerts go to the right person the first time, right? We don't want to have 80 alerts go off when one issue comes up. right? We want to have the one incident that goes to the one person who knows how to log in and fix it. So this gets rid of alert storms and really helps lower our MTTRs. So now that you know what the product does and what sort of features are included, I'd love to hand the presentation over to Ram, who will tell you about how we actually use it to monitor the Observability Cloud itself. Ram, take it away.
Thanks, Greg. Plus one to what you said. One of the key value props of the Splunk Observability Cloud is having all the pillars of observability in a single pane of glass. By pillars, we mean basically, when do you find an anomalous event is happening? Where do you find it? How do you debug it? And who is impacting? Getting all that information in a single pane of glass is super helpful. Like Greg said, my name is Jothikumar. I run cloud infrastructure, SRE, and operations for Splunk Observability, and my teams are responsible for building, deploying, and operating the web scale platform that actually supports the Splunk Observability Cloud. Prior to Splunk, I've been part of two industry-defining tech innovations, one around observability and real-time monitoring with SignalFX, which was acquired by Splunk, and then with software-defined networks and VMware and ICEDA. All right, let's talk about how Splunk uses Splunk Observability Cloud. Splunk has various platforms and products, and Splunk Observability Cloud is used as part of this. Splunk Observability Cloud itself, we use Splunk Observability Cloud for our own monitoring. I think of it as dogfooding. And the primary vectors here are, the first one, monitoring availability for customer-facing services. Right? These are services that customers depend on and use on a regular basis, monitoring these 24/7, 365. Monitoring code deployments. We are a SaaS service. We have a continuous integration, continuous deployment. So whenever we push code, we use our own monitoring platform to make sure the health of the code deployment and such. Monitor the health of microservices that make up the Splunk Observability Cloud platform. This is so that we can find early indicators of any anomalous behavior so that we can catch it at time before it impacts the customer-facing service. Customers have been using and growing in our platform right from the get-go, and monitoring their usage and capacity for handling their growing needs is something that's very important for us. All right. Before we dig deeper into how we use Splunk Observability Cloud, I want to take a few minutes to talk about what Splunk Observability Cloud is. That will set the right preface for why we use Splunk Observability Cloud. So I think the cloud is a microservices-based platform with a lot of complex dependencies that is typically attributed to a microservices-based platform. We are born in the cloud, use a lot of cloud-native tech, some of which you see here. The Splunk Observability Cloud it's offered as a SaaS offering, and it's deployed in public cloud providers. And this is important to mention because at the end of the day, you're running an elastic infrastructure that is dynamic and can elastically scale. The third aspect of our Observability Cloud platform is its volume, which we actually pride ourselves with. What you're seeing here is key metrics around the volume that we handle. A couple of points I would like to just focus you is, if you look at the Kafka volume, we do about like 1.2 trillion messages a day. We ingest about like 32 million data points per second. And doing all of this, we keep our latency within 1 to 2 seconds. And you can see on the top right side, the number of, the scale of our open source third-party services that we used to handle. And the reason I point to all this is to give an idea of the complexity of the cloud, which in the next few slides, we talk about why we need a sophisticated tool like Splunk Observability Cloud to monitor this. So by now, it's probably clear to the audience that we need a pretty sophisticated set of tools to monitor a highly scalable, elastic, complex platform which is Splunk Observability Cloud, right? Which is very, very common to what most of the web scale platforms out there do. So here are the features that SRE teams and Splunk Observability Cloud teams rely on to monitor ourselves, right? Number one is real-time insights and analytics. Given that uptime is something that's very important to us, which you've seen in the following slides, real-time insights is very critical to meet uptime SLAs, right? When you're talking about like 3 nines and 4 nines, uptime SLA, like every minute counts, every second counts, and sometimes you have like auto bots that actually react to an incident and can auto remediate. So in these cases, seconds count as well, right? The faster I can get to MTTR, the better it is. So real-time insights are extremely important for us. The second one I would say is full fidelity and high cardinality. Our tracing, with tracing, we get like full fidelity tracing. We have unlimited cardinality in our metrics platform as well. And both of these assist us in sizing and dicing data to get to the root cause really quickly. And you'll see this in the demo later. Between real-time insights and full fidelity, high cardinality, it gets us get to the root cause really quickly. The third one I would say is like handling high churn. In today's elastic environment, where you're using Kubernetes or any of cloud orchestration tools, churn and elasticity is a given, right? And having a platform that can change its scope based on elasticity is something that's extremely important to us. So that way, even with changing scope, you don't lose insights to it. Last but not the least is powerful analytics. Given the volume of data and the streams of data we get, having sophisticated analytics, which is basically like math functions, right, and data modeling, to help catch leading indicators of anomalous behavior is something that helps us catch an issue way before it impacts a customer, right? And in a very complex environment like ours, this is something that's extremely important as well. All right, so far what we spoke was what is the Splunk Observability Cloud, and then why we use Splunk Observability Cloud to monitor ourselves. So let's talk about the mechanics of how we do it. All right, so it's all about service uptime here, right? This is in fact our primary guiding factor to define how we use Splunk Observability to monitor ourselves. And the reason is pretty simple, right? Customers depend on us. Customers use us as their eyes and ears to the health of their systems. It's extremely important for us to keep the service uptime. And just to get the numbers clear, right? Like 3 nines and 4 nines, right? What do they really mean from a time standpoint? 3 nines is really you have 43 minutes of downtime in a month. 4 minutes is you have 4 minutes of downtime in a month. Remember I spoke about real-time analytics a couple of slides earlier? Now it becomes really real, right? Like 4 minutes of downtime in a month means you really can't afford like minutes or seconds. The sooner you get to MTTR, the better it is. So keeping up with uptime starts with monitoring, right? Monitoring is a 24/7, 365 job. And we use a dedicated monitoring instance of Splunk Observability Cloud for this. It's a production-grade instance, which is completely isolated from any of the other customer-facing instances, and telemetry gets pumped into this, and we monitor here. We have about 500 plus pitch detectors with focus on SLI KPI metrics that page on call when an anomalous behavior is detected. Most of these are tuned to be leading indicators, while some of them also alert us when an event is happening. We have a rich set of runbooks and auto remediation tools that upon detection of a incident, they get triggered, right? And they help with either debugging automatically by themselves or humans who are paged and then eventually fixing the issues. We have service owners go on call 24/7/365. And note here that I'm not talking about NOC teams or SRE teams, but service owners. And we'll dig into that in a bit. And then we have engineering leaders on call to help make hard decisions and provide support. So like I mentioned in the previous slide, we use a dedicated instance of Splunk Observability, and that's kind of what you're seeing here. We have about like 5 to 6 regions of Splunk Observability deployed across the globe, and we have telemetry from all of that pumping into our monitoring deployment. And just to give you an idea, we have about like 8 to 10 million metrics. It's a rich set of metrics that get pumped into monitoring. And then here is where we have sophisticated alerting, and we use Splunk Observability's features, right? Like which is alerting as a key feature in there. And based on sizing and dicing of the alerts, based on analytics, and by how it can be tagged by different teams, we pipe these alerts to the various on-calls. And what you're seeing here is the service owners for that their specific services getting paged right at the start, right? So you're not, like I said earlier, you don't have a CNOC layer, you don't have an SRE layer. Because of our powerful analytics, we're able to fine-tune the alerts to page the service owners. And I've just mentioned a sample of these on-call rotations. So you have the ingest pipeline, which is a separate on-call rotation. You have the query pipeline, you have the application pipeline, then you have the infrastructure, and then you have the data pipelines. And then you have an incident commander who helps, who provides support in all of these areas. Digging a little bit deeper into how we distribute our on-call rotations, We call this a distributed incident response, and the primary reason we did this was to reduce MTTR. The first item here is around our culture, right? It's a DevOps culture. What this really means is service owners are on call for their own services. You write code, you own a service. We believe you are the best equipped to understand that service and debug that issue quickly. So why not you as a service owner be on call for your own service? And related to that, we fine-tune our alerts using our powerful analytics and high cardinality to be able to page the service owner directly, right? Like because of the feature sets we provide, we're able to slice and dice our signals based on dimensionality and figure out exactly which team is responsible for that or which part of the system this is happening in, and able to direct the alerts to you, so that way you can take action on that. So like I said earlier, we don't have an NOC team nor tiered SRE teams. We just page the specific service owner, and obviously before they get paged, we have machinizations to make sure we can automate or we can auto remediate and get humans involved only when the machines cannot handle it. And this has significantly helped us in reducing MTTR. What this also means is we also want the service owners to manage the monitoring content, because they're the subject matter experts and the service owners are making changes all the time. So it makes sense for the change for the owners of that to also handle the monitoring content. While at the same time, we also want to make sure standardization and high quality of monitoring content is there. So while the individual service owners own the content, we make sure we use principles like monitoring as code for standardization. And here is where the SRE team helps by providing the right tools and the methodology for all of these. So I want to emphasize a bit on the fact that we don't have traditional NOC teams or SRE teams that are basically click buttons or like middle tiers. And this is primarily because of the feature sets the product provides, which helps us get an alert directly to the owner of that. And this has actually helped the SRE teams focus on basically improvements in other areas. So one of the unique things with us is the SRE teams actually are service owners. SREs actually own critical open source services, and we have found that having SRE have a skin in the game is very beneficial for the culture and for the other areas that SRE provides benefits, right? Like SRE builds tools for auto remediation and evangelizes availability best practices like SLOs, SLIs, and methodologies around that. And having SREs be part of service ownership and kind of understand what it takes to be a service owner really helps with this. SREs also help with analyzing and providing insights into outages. This actually helps catch trends and as part of our patterns, right? Like our chronic issues that may be happening in the system, and catch that early on before it heavily impacts the Splunk. All right. So what I presented so far hopefully gave you an idea of how we use Splunk Observability Cloud to monitor. Kuba Barc, who's a senior SRE within the team, is going to walk you through some workflows and demos to kind of show you how it's really done. But before I let you guys go, I kind of want to make a couple of statements. Number one is, in today's world of microservices, web scale volume, evolving and dynamic elastic infrastructure, availability incidents are a reality. Having the right monitoring tools, processes, and teams makes the real difference, right? Between how you react to it, how proactive can you be, and how quickly can you resolve an incident. And monitoring with Splunk Observability Cloud, it definitely helps reduce MTTR. Using Splunk Observability Cloud frees up teams to focus on improving reliability, stability, rather than being redundant layers in incident response and incident management. With that, handing it off to Kuba. Kuba, take it away.
Thanks, Ram, for introducing me. My name is Kuba Barc. I work as an SRE in Splunk for 2.5 years now. I'm part of the SignalFX acquisition, just like Ram, who happens to be my manager. I have a history of working as a software engineer in backend and SRE in really numerous companies. And my presentation here today, what you're about to see is our actual Mon deployment. This is what Ram mentioned. This is our own private instance that we are using to monitor the entirety of our production deployments. So that's kind of one aspect of that. The other is I'm not going to only tell you about what SREs are doing, because these flows that I will take you through are also common for our developers, right? Our company really wholeheartedly embraces DevOps culture. If you wrote it, you run it, you're responsible for monitoring that, you're responsible for deploying your software. We as SREs, as a team, we are providing the grease to the cogs. We try to make stuff easier. We keep track of scalability, the platform itself, the tooling. We also own third-party services. You actually might recognize this chart. This time it's live. That's the chart that Ram had in his slide deck. That's our bragging chart, right? So if you look at the number of almost 33 million data points every second, if you multiply that by 60, that's almost 2 billion data points that come every minute, which is kind of pretty impressive and gives me a lot of pride. Okay, so I'm going to get you through kind of typical use cases of how we would use our own product. That would be, well, the very basic one of detecting stuff, detecting an incident and reacting to that. So how are we detecting and monitoring various incidents that might happen? The RCA, meaning the root cause analysis, like now that you know that something is going on, how can you go and really quickly pinpoint to what exactly is going and what caused that and how do we fix that? I'm going to show you how we approach scaling and how we are using our monitoring tool to know when to scale. And I'm also going to show you our APM product and how can you use distributed tracing to find stuff very precisely that otherwise might be missed if you're only using infrastructure metrics. Okay, so let's begin. Imagine a scenario that you're receiving a page, I don't know, that could be, this Splunk incident response, that could be PagerDuty, that could be a message on Slack. Some way you are informed that stuff is happening. And in a typical scenario, this is what you would see after clicking the link, right? So what I'm showing you right now is an actual alert that has been triggered about 3 hours ago, I believe. This particular one is one of the proactive alerts that we have. Just to kind of give you an idea, there are some alerts, and these are pretty critical ones. These are the ones that will page people that are usually about the SLI breach. So when we know that stuff is really critical, you have to drop everything you're doing and address the issue. But we also try to have proactive alerts, and the big chunk of this alerts that we have is as you can see over here, is we know that in this particular cluster, if the increase in disk utilization would continue the way it is right now, in about 2 weeks, it will just cross the thresholds that we considered safe. So it's probably a good idea to look into that, but you don't have to do it right now, right? So we still have 2 weeks. There is another alert about the same event that might occur within 2 hours. And there's also an alert that actually tells you that, yes, we've breached some safe thresholds. We should definitely, at this particular moment, just drop everything on the floor and address the issue. Just to show you how it would look like. So this is an example of a detector for one of our teams. This is the Beavers team. So you can deduce that it probably has to do something with logs. For them, this is the critical alert that would page if their actual SLI target is being broken, like either the one to our customers or the one to our internal customers, right? Because like we ourselves within teams also have customers. So this is how the example alert would look like, and every team configures the way that they are receiving alert by themselves. So the only constant there is if there is a critical alert, you are getting paged. Depending on the team that you are in, the different on-call rotation can be paged. But every other alert, like the major, minor warning, just kind of informational alerts, not really an alert, but just info like FYI. Depending on the team, they would configure it themselves because it's essentially up to them how would they monitor their own product. One other thing that we also try to do is like our infrastructure supports automated muting. So if we are running some sort of procedures on prod, then in most cases our tooling would make an API call to Mon, telling it like, listen, mute this alert. Like we expect that to happen. Like, I don't know, we are rolling this cluster for security patches. So the latency can go up, but in this case, this is expected. So, I mean, don't page people, don't alert people. If you look at the detector itself, you can notice that the detectors that we create are basically using signal flow, which is the Python-like language that is underlying every chart, every detector that we have. And at some point, people just stop liking, just clicking on the UI to create their detectors or their chart because they can use code. Like to me personally, I prefer code to UI. And what we also did, because we have like hundreds of these detectors, to keep track of them, to make sure that we don't lose them, they don't drift apart. We decided to do encode them in we have a tool called ACDC, and most of our detectors that we have are coded as a small Python, the piece of Python code that would allow you to generate your detector and then create numerous copies of that. I mean, for prod, for lab, you can test your detector beforehand. Okay, so that's kind of how we know when we detect stuff. What else can we go and monitor? So the dashboard that you're seeing right now is what we call ECAM. ECAM, I believe, stands for Electronic Computerized Aircraft Monitoring. I might be wrong on that, but not by far. Basically, this is the all sets of these dials that pilots see. And we find this really fitting because if we didn't have that, we would be completely flying blind. We don't like flying blind. So this is the kind of chart that we are using to drill down to answer, you received an alert, that something is happening. How would you figure out what exactly is happening? So what can you monitor? In our case, if you look at the example dashboard that we have, you can monitor data coming from application itself directly. You can go and monitor CPU utilization. You can monitor disk utilization, network, errors during, like, whenever you have network errors. Most of our stuff is running on JVM, so we do take metrics directly from Java virtual machine. We get, again, application metrics like buffers. What's the state of the buffer? How many requests did your application handle? What's the latency? Right over here. Interestingly enough, a little bit of a side story. Arijit, who was the CTO of a company still back at the SignalFX times, created a bot that he integrated into Splunk, into Slack outage channel, where he would monitor how many people were talking at specific moment, and if people started talking too much on the outage channel, I mean, this basically is a metric, right? Like how many people are talking right now on outage, and if this crossed certain threshold, it would actually ping him, letting him know that there's probably some sort of outage that he could go and look into and help. So at some point, you can also start monitoring people, in a nice way. And this really becomes addictive. you get more and more data that you could go and measure. Okay, so that's kind of the first flow of kind of detecting and monitoring in general. How would you do a root cause analysis? So I would give you an example that happened a little bit more than a month ago. I got paged because like Elasticsearch is a bit of my thing. I got paged that one of our internal clusters, so that wasn't really impacting our customers in any way, suddenly turned red. Like this is the information that I received like right away. The moment that cluster went red, about a second ago, yeah, there was a page like there's something wrong with this cluster. And how would you figure out like really quickly why did the Elasticsearch cluster become red? So you open a chart like that you know I have prepared beforehand just to monitor my clusters. And first thing that kind of pop when you look at that is yeah, there is a spike in CPU. There is clearly a ton of memory pressure on the data nodes. But like, what could cause that? Well, like, why did that happen? Like, why is my cluster red? And yeah, very quickly, just because we have that already prepared, and we aggregate data from many sources. Like there are infrastructure metrics, there are metrics taken directly from the cluster itself. We really quickly were able to pin down that the volume of indexing requests jumped from like 1,500 to 15,000, basically within a span of minutes. So this really quickly told us that yes, we are getting so many indexing requests that our nodes are basically umming, and they're obviously starting again. But during the restart of the pod, if too many pods are being restarted, the cluster actually is going into the red state, the state that is basically unoperable. But again, we were able to point really quickly, it's the indexing request. And it turned out that somebody just kind of flipped a switch and started sending way more data than we anticipated. Okay, so that is the kind of second use case scenario, like how can you drill down to the problem really quickly. Third one is how we approach scale. So just to show you, this is also one of kind of my charts that I use to figure out like when is the time to scale up certain Elasticsearch clusters. I mean, it's all there. It's a matter of getting the data and putting them into one place. And every other week we would hold a meeting trying to figure out like if now's the time, do we scale up, especially that, you know, the database like services are not, I mean, they are stateful, so they are not as easy to scale up as our stateless services, which are very often just like automatically scaling up. So we would hold that kind of meeting. All of us have our charts, and like, yeah, I mean, this clearly means that I have to go and this is one of our internal clusters. I would have to go and scale it up, which is probably what I'm going to do really soon. Another way we are approaching that, just to show you the kind of magic that you can do if the data that you're receiving, you're able to process it and analyze it really deeply. So what you're looking right now is a piece of code that one of our SREs did, where you're taking metric time series creation rate and CPU utilization over a long period of time. You would, and this is all kind of all streaming data, you would calculate the regression coefficients just to kind of roughly give you an idea what's the proportion, to what extent CPU utilization and MTS are linked, and based on that data, based on the the beta value, the value of a slope, you could go and based on current data figure out if we are if our CPU utilization compared to the creation is high enough, if we are using the capacity we have in a proper manner, or we are over or underutilized. So this is all the kind of magic that you can do with our analytics engine, and it's really, really awesome. So that's the scale part, and the last piece of a puzzle, the last flow that I'm going to show you is the kind of insights that you could get if you have distributed tracing, because like very often you could have stuff that is just missing if you're only using infrastructure metrics. So again, this is all this is live data that we have. This is the tool that we are using. So this is the automatically generated map of our infrastructure, the deployment that we call US1. And well, the first thing that grab attention is there are red lines and they are red boxes, and what do they even mean? So we can go and well, let's go and examine that. In this case, we see that there is a heightened error rate between the cluster called SVC trace analysis API and Presto. If we go and check like what exactly caused this high spike, we can see example traces, and we would like to examine like where do the errors come from? Like we don't see them anywhere else. Like what is causing these errors? And if you go and examine an example trace, then very quickly you would go and get information like what's the error? Yes, there is some form of error. That's SQL exception, and this is the database statement that we were running against Presto, and clearly there is something wrong with that. So if I were the owner of this particular service, I would clearly get information like this particular thing is broken. We are having errors, and we should probably look into that and fix that. Right. Let me now present kind of looking at data from a different perspective. I will be showing you a service called MAT. The service MAT is well, it has a funny story. Like why was it named MAT? It's clearly a name. And service MAT is basically a proxy that allows to query different data sources, be that Elastic or our homegrown Meatballs database. Well, basically the request comes to Matt, and then Matt knows what to do with that particular request. In this particular example, and let me just select 12 hours of data. In this particular example, we'll be looking at latency. You can notice really quickly that we are looking into like we would have P50, which is mean, P90, and P99. The reason why every one of these requests is measured on the mean, the 90th and 99th percentile is even if something happens one every 100th time, but it's taking too long, it can very visibly affect either the performance or the way that customer uses our product, and what experience would they get. So again, we are getting a really nice view of this service and the latency issues it might have. We can see if that particular scenario impacts one of our customers, or if it's related with a workflow, or if it's related with one of the nodes that we have. Let me just select one of these. And yeah, technically we see that with this particular, well, we call that endpoint. In some cases, and this is the invocation responsible for filling the tooltips, like when you're pressing on your UI, and then you want to kind of give the customer the options to choose, like what exactly is that you're interested in, especially like for this set of customers. Sometimes it's taking way too long. Like 6 seconds, come on, like who would want to wait for 6 seconds to have the data shown to them? Like, people can start complaining that it's clearly broken. And just bear with me a second. We'll see one of the trays to figure out like what exactly was that and what was involved. Like, why did it take 5 seconds? Yeah, there is the whole flow of this request, starting from getting the request from the customer through all of our intermediate services. And the last one, if you go and click on that, we see that Matt, this service, was actually doing a query against Elasticsearch Metabase, one of our cluster. This is exactly the query that there was, and that it took 5 seconds. So this is an indication to me that I should probably look into that cluster and see why did the query took 5 seconds, and is there anything that I can do about it. Cool. So that pretty much sums up my presentation, my demo. I really hope you liked it. I know I did, and like I'm using this tool every day, and I just can't get enough. And with that being said, I'm giving back to Greg.
Awesome, Kuba, thank you for that demo. It was great and gave me a lot of flashbacks to when I was in SRE troubleshooting. I wish I had some of these tools. It would have been a lot easier. But thank you all for paying attention during this presentation and for asking questions throughout. If you haven't asked questions, we still have plenty of time for that. So go ahead and pop those into the Q&A panel, and we'll try to get to you either during this presentation or we'll send you an email after and give you an answer. But a bunch of questions have come in, so I'm going to throw this first one over to you, Ram. How has monitoring at Splunk changed since the Observability Cloud acquisitions?
That's a good question. It's been actually evolving as and when Splunk has been making acquisitions and or new tech has been built in-house. Splunk has been a logging company, like you mentioned earlier, and Splunk has been using logging for a lot of its monitoring, and for infrastructure monitoring and APM purposes, Splunk was using some of open source tools. With the acquisition of SignalFx and Omnition, we started switching towards infrastructure, metrics monitoring, and APM. And a lot of Splunk's core enterprise products have actually switched to that at full volume. With the acquisition of Flowmill, Rigor, and Plumber, we started using some of Synthetics and also like network performance monitoring as part of this. And now with Splunk Observability Cloud being a suite, a single pane where everything can be integrated along with Log Observer, the various Splunk platforms are actually switching to this as well. So it's been like very beneficial internally, not just for Splunk Observability Cloud, but all of Splunk to start using this.
Yeah, awesome. I agree, and I think I'm excited to see some of those other products like network performance monitoring being more integrated in the future. It's really something to look forward to. I'm also going to give you the next question. Have you seen any improvement in MTTR over time?
Yes, absolutely we have. And I think it's because of two reasons. Number one is, like I mentioned earlier, we've been fine-tuning using Splunk Cloud's like powerful analytics and other features to get an alert or an anomaly to the right individual. And we started with like having a single on-call rotation, now with many more. And the more fine-tuned we get to, where we reduce the scope and we get the scope closer to where the service owner is involved, we've seen significant improvement. That's number one. Number two is, as we've been having more and more feature sets, right? Like now with network performance monitoring and with Synthetics, we're able to get rich information, right? All the pillars of observability to the service owner. So we're able to get to the root cause much sooner than earlier. So because of these two, we've been able to make significant improvements in MTTR.
Hey, awesome. And since you mentioned the larger number of teams, one last question for you for now is how many different on-call teams are there?
We have about, I think, 6 to 7 on-call teams, and we have a process where we roll out on-call teams as and when we grow teams to the point where we want an on-call rotation to have a set number of people, so that way the knowledge is not lost. So like it's about 6 to 7 right now.
Yeah, cool. That's, on-call is a lot of times people, SREs describe it as one of the worst parts of their job, but keeping the team small and making sure that everybody knows everything about the service definitely makes it easier. So, Kuba, I've got a couple of questions that I think you're best for. what sort of issues do you encounter most frequently when you're doing your on-call rotations?
Oh, so that's an interesting question. I think the most of the alerts that we get are related to the infrastructure. Think about it like containers restarting. If they are restarting too often, then the owner of the service gets paged. There are definitely some like CPU disk, like basic utilization ones. Like if we are, for instance, deliberately running some cluster a little bit hotter, then we can expect this kinds of alerts coming. And one other group that is, as far as I know, pretty distinct in the flow that we have is like sometimes you can have we're a multi-tenant, we have multi-tenant deployments, and you can expect the noisy neighbors. We try to block noisy neighbors, but this actually requires some person initiating contact with a customer, telling them like, listen, we had to block this particular job or this particular thing that you did, and like FYI, this is what we did. You should probably do it a little bit different next time. So again, if it requires human intervention and reaching out to the customer, that's like people have to get paged.
Yeah, that's an interesting approach to have to reach out to the customers. I never was that lucky. I could just do whatever I wanted, but having to do that as well is a fun challenge, right? So one more question for you is, how would you find issues in upstream or downstream services? I mean, I know that was the cause of all the services I ever maintained. It was somebody else's problem. But how would you find issues in upstreams or downstreams with Splunk Observability?
Okay, so I think there are two approaches here, and one is, as I mentioned in a demo, like if you're having your sets of charts, if you have your place when you're starting digging into the problem, analyzing the problem, then the good flow and the good practice to do is having the charts and dashboards from other teams just copy it over to your dashboard, right? So you can very quickly see what other services that might be impacting your services are doing. So that's kind of one facet of that. The other, and say in this case, I'm talking strictly from my team's perspective when we are managing all the third-party services. We are getting metrics both from the cluster itself as well from the client libraries that are using our clusters. So in this particular case, if there are errors that are being reported from the client libraries from our internal customers, then I would get information that this team cannot use my service, right? So I already know who's that particular problem impacting.
I think one thing I'd also add to that is, like we use the application performance monitoring like service mesh and service graph to be able to find what the upstream and downstream services are for an issue that's happening. So that way I can really get to the where, right? So that we, plus one to what Kuba said, we also use a service graph for this.
Yeah, the service map's a really impressive feature, and it's something that, I was hoping one of you would mention as an answer to that, because it's really great. So I think this is all the time we have for live questions. We do just want to make sure that we're respectful of all of your time for attending. If you have questions that we haven't answered in the chat already, like I said, we'll try to chase you down and send you an email with an answer. But otherwise, we just wanted to say thanks for the questions, and thank you. Thank you all for joining our webinar, and a special thank you to our speakers, Avram and Kuba. I hope you all really got a lot of value out of this. And like I just said, if we didn't answer your question, we will follow up with you by email. Just so that you know, we did record this, so we'll send out the recording. You can share it with your friends. If you really want to make sure that people understand like how we do the job of monitoring and how we use observability, please feel free to share it as widely as you can. If you haven't gotten a chance yet, we'd really like to ask you to please take our survey so that we can understand what kind of content you want to see. and make sure that you check out our related resources below for more on Splunk Observability. We also have a free trial available. We have a ton of resources that we're happy to share with you. So thank you again for attending. Have a great rest of your day.